Okay, you will find, just quickly going through this unit packet, that there are no proofs here. Okay, you probably won't see a proof until, what unit are we on? 8, unit 10. All right, so we got a couple, but on the flip side, this unit is a very heavy algebra unit as well. Okay, very heavy algebra unit. Okay. All right, so this first topic we're going to do today is a 2-day topic. The intro's today, the honors level questions are tomorrow. All right, last unit, we dealt a ton with proportions. I gave you some, asked you to solve them. You created your own, solved your own. What I want to start off this unit with is a 2-day topic called a mean proportional, which is a special type of proportion. Guys, remember doing the means and extremes. Okay, let's just a quick review of what are the means and what are the extremes before I show you one here. A over B equals C over D. Where are your means located? Means are B and C, and where are your extremes located? A and D. A mean proportional is a proportion in where the means are the same and the extremes are different. Let me show you a quick example of a mean proportional. 6 and 6. Everyone see where the means are the same? Extremes will be different. Okay? And the extremes are different. The means are the same, but the extremes are different. And everyone agrees this proportion's correct, right? 36 equals 36 when I cross multiply. Okay? We say the mean proportion here is 6. Okay? The mean proportion is 6 in this proportion. All right, so my first example here real quick. Find that mean proportional when my extremes are 4 and 16. All right, 4 and 16. So I'm looking for the means. So what's a good idea here to put for the means? X and X, they're both the same. So for the means, they're both the same. And what are those 4? What's the 4 and the 16 actually acting as? Those are my extremes. The means are always equal in a mean proportional. So we go ahead, we cross multiply. X squared is equal to 64. Square root both sides. X is equal to, gotcha. Yeah, it is equal to 8, but also doesn't it work if I plug a negative 8 in there? Right, I'll get positive 64 too. So it is plus or minus 8. But as you guys know, we'll probably be working with diagrams, and the negative probably is not going to fly. So then we turn our attention to what's called the geometric mean, which is the positive value in this situation. All right, so geometric mean is the positive mean proportional. All right, the positive version. So find the geometric mean of 15 and 20. 15 and 20. So a mean proportional, but now instead of doing plus or minus, I just want the positive version when it asks for the geometric mean. All right, so let me open it up to you guys. 26, set up a nice proportion here to find it. Got it. X over 20. Again, I'm looking for the positive version now. In simplest radical form, of course, because we are in honors. So x squared is equal to 15 times 20, 300. Let's break down 300. Some of us still had a couple issues on the unit tests, breaking down the number underneath the radical. Most of us did a nice job, though. Biggest perfect square that goes into 300. 100 times 3. So my geometric mean here will be 10, not plus or minus anymore, because the geometric mean, I'm looking for the positive value, right? So 10 radical 3. If I ask for the mean proportional, yes, it would be plus or minus. But if I ask for the geometric mean, I'm just looking for the positive version. All right, we okay? Because I'm going to relate this now to similar triangles from last unit and where this can be used. All right, let me do that. Okay, We got a special case for similar triangles. Special case. Here's the requirement I'm going to give you, and you can copy down my diagram because I don't think we gave you one. Nope. We have a right triangle with an altitude drawn from the right angle to the hypotenuse. So you can go ahead and draw that out for me. And then we'll get into a lot more detail. Okay, let me just show you what you just did. Does everyone see the right triangle CAB? Where's the altitude you drew in? AD to hypotenuse CB. Okay, that is the requirement you need to use what I'm about to show you. You guys probably don't realize this now, but you are in a second. Take triangle ADB for me. Compare it to the big one, CAB. They both have what type of angles? Right angles, and they both share which angle? Angle B. Let me say that again. They both have right angles and they share angle B. What do you know about those two triangles? They're similar. Ding, ding, ding. Next up, take triangle CDA and the big one. They both have what type of angles? Right angles, and now they share what angle? All right, so what do you know about CAD and the big one? They're similar. One more. This triangle is similar to the original, and so is this one. So what can I say about the two smaller ones? They're similar. Bottom line, all three triangles in this diagram are what? Similar. Let's take it to the next level now. Because they're similar, what do you know about their corresponding sides? We did all. You're going to tell me the sides are similar. If the triangles are similar, what do you know about their corresponding sides? They're in proportion. If I asked you to create a proportion, I think we'd have mass chaos in here to match up the sides. Because I saw what you did with the one problem still on that unit test. All right, and it was, I don't know what happened there, but we'll discuss it when I hand it back. So be prepared for that one, Ella. All right. But if I asked you, if I asked you right now, I would not blame any of you if I said, what does side DB match up with in the big one? We get a bunch of that, and I'd have to wait forever. Okay? If I asked for what would CD match up with in the smaller triangle, we'd be here for a while, some of us. Okay? And I don't blame you. Some of you can do it like that, and some of you would be here for a while struggling to do it. So what I have for you today is, to set up these proportions, 2 devices that will match them up. All right? For you already. Before I introduce those devices, we need to talk about all the different segments that have been formed in this diagram. What's AD is probably the easiest. What do we call AD? That's called my altitude. All right, so AD, let's label it. That's my altitude. CB. Somebody give a name to CB in this right triangle. Hypotenuse, nice. That's the hypotenuse. How about AB? Yeah, if it's not the hypotenuse, it's got to be the leg. And the same thing could be said for what? CA, that is also a leg. There are 2 segments we have not labeled yet. And that is CD and DB, the one the altitude broke the hypotenuse into. So, and all we're going to refer to those 2 are as segments. All right? Segment, segment. So how do I match up all these corresponding sides now without having mind freezes? All right? The first device I'm going to show you is called Hills. Hills. H-L-L-S. All right? There's no I in there, just Hills. All right? However you kids want to pronounce it on the street. All right? Hills. What's it short for? Ready? The H is the hypotenuse in the diagram. L for leg. L for. Now the first question that's going to come up is what? Well, which leg? And that's probably either going to be the one we're looking for or the one that's labeled already. But same leg or the two different legs? And it's going to be the same. You know why? What are these right here in the proportion? The means. Hey, these are the means. And while we're doing our mean proportionals today. So the means are still always going to be the same. So this is the same leg. So if you put AB here, you got to put AB there. If you put AC here, you got to put AC here. It's the same leg. The means are always going to be the same. And then finally, the S. And you probably come up with the same question, which is, which one? You got two of them. Ready? Whatever leg you pick, it's got to be the segment adjacent to it. Quick test. If you pick leg AB in the problem, what segment are you going to use then? The one adjacent to it, DB. Okay? S is the segment adjacent to the leg we are using. Everyone good there on hills? Now, well, sometimes hills isn't going to cut it. It's not going to cut it. Maybe I'm given some other information and I can't fill out hills. So I have a second one, and this is why I went so hardcore on everyone when we proved triangles congruent, when I introduced SAS, and kids were like, SAS. And I said, no, there's actually a SAS out there. And it's right here. How to match up the corresponding sides. Ready? S. A. A. I'll ask this. Same or different? Well, there's only one in the darn diagram. Okay? No matter if you realize these are the means and they have to be the same, there's only one in the darn diagram. S. Okay. If this is a mean proportional, same segment or different? Different, because the extremes are different. So these are the two segments in the diagram. All right? That's what we're going to use in these type of diagrams to match up the corresponding sides. We all good? Okay. Let's try this out now. Let's try it out. And you'll see I don't have much for you. Tomorrow's really, we're going to get real in depth with this. All right, don't try to be a hero and solve it on your own. I'm going to make this very easy on you. First of all, does everyone see a right triangle? Do you see an altitude drawn to the hypotenuse? Because that is huge. When you see the altitude drawn to the hypotenuse, that's ding, 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 hills and SAS time. All right, that's the only type of diagram I can use hills and SAS. Right triangle with an altitude to the hypotenuse. Now, the second thing is going to come into problem, which is going to cause an issue, which is, which one do I pick? Okay, hills or SAS. You answer one and one question only. Everybody ready? Is the altitude labeled at all? No, your question is answered. What's the only thing I can use then? Hills, because hills does not involve the altitude. All right, so we are going to use hills here. Hypotenuse over leg equals leg over segment. Okay, where is the hypotenuse on this diagram? Where is the hypotenuse? Remember, we say hypotenuse, it's the hypotenuse of the whole right triangle, which would be right here. How long is that hypotenuse? 12 over what leg? It has to be, because I don't know anything about the other leg. So some of you asked at the beginning, which leg? Well, it's got to be Y, because I don't know anything about the other one. So Y. And what do we know about the legs and hills? They're the means, right? Even if you forget that, the means are always the same. And then if you got to look back, what segment do we pick? Because I could pick 3 or 9. Why are you picking 3 back there, Ryan? It's adjacent to the leg we're working with in the problem. So 3 instead of 9. Got it. Okay. The cross multiplication shouldn't be bad today. Y squared equals 36. Y equals, well, I do get plus or minus 6 out. But I got a diagram here. -6 isn't going to cut it for a side length. So it's just going to be 6. I don't need to see it. No, I don't need to see the rejection. Nope. Okay. Okay, next one. Right triangle with an altitude to the hypotenuse. Is the altitude involved? Yes. Yes, it's labeled as the X. There's only one device I can use, and that's the SAS. Okay, here we go. Segment. Segment. Either one, 4 or 12. It's up to you. Altitude. Watch this. Other altitude. There is none. It's just X. Yes, only one altitude. And now S. Same segment or other one? Remember, extremes got to be, even if you forget, the extremes got to be different. So it's got to be a different number than 4, 12. And yes, all today, tomorrow, leave your answer. Simplest radical form, please. No decimals here. Take the square root, take the square root. Biggest one, 4 is not the biggest one, everyone. 4 is not the biggest one that goes in the 48. It is 16 times 3. So X will be 4 radical 3. A lot easier than trying to match up the sides yourself. And how about this last one here? Is the altitude involved? Okay. So we'll have SAS. Let me go around the room for this one here. Here we go. Number 5, segment. 2, altitude. 19, altitude. Oh, one jab. 30, altitude. 3. Altitude. 20, altitude. 3. Segment. 9. X. Got to be different. 2x equals 9. So X will be, 4.5. Oh, they will get tougher tomorrow. Okay, they will get tougher tomorrow, but you got to make sure you get the basics down. Okay, so you have the bottom of that page for homework, some problems out of the textbook, and remember your Regents question for tonight, all of which can get done in the next 20 minutes without a doubt. Stay right where you are, please. Don't move around. Let's get it done.